Hello conservationists. In this video we're going to do an overview of the Water Erosion Prediction Project, or WEPP model. So this is one of the more recent models that the ARS and NRCS have developed, and it's kind of become the mainstream erosion model used today. And we're going to be using a version of it that is focused on a single hill slope, but there are other versions that look at catchment scale erosion modeling. But let's switch gears here, and I'm going to. So this is the model here, and you can. There's a link to this in the laboratory manual, and so eventually you go to NRCS page, which will eventually take you to this model interface. And how the model is set up is there's some different sort of parameters that we can set at the top of the screen. It's not showing my cursor for 1 second. Give me one second here. There it goes. Okay. So there's some information at the top where you can kind of fill out the basic information about your site, and then we can get into how we actually set things for different sort of management and so on. So let's do a few things here. So our client, what we're going to do today is we're going to use our example from our Saturday field trip that was that occurred, I think, back in October of 2024. And our client in that case is our farm manager for the Grammy North Farm, Dustin Ritter. And then the farm is, or the field is a Grammy North Farm field B1, I believe. So we'll go ahead and put that information in there. And then I want to change some of the information. So it defaults to Adair County in Iowa. So I want to change that, and we'll go to Kansas and Riley. And then it has like a default climate database. It's going to default to a 100-year simulation. So it basically simulates weather patterns based on the last 30 years of data. So it says climate database 2015. So it goes from 1985 up till 2015, I believe. And then we can adjust our particular map to basically simulate weather for the farm. And our field that we're going to use is right here. And I believe you do draw a marker, click that, and we'll say Grammy North Farm B1 and save field. And I think that's all set. So we can go back to project, and so now it should be able to kind of use that location. Now, there's a few other things we want to change. So notice up here there's no soil it's set. So let's go ahead and change that. And I need to change my view here. Yeah, it's not going to let me. There you go. All right, so here's Google Earth Pro, and what I have set up here is the SoilWeb KMZ file that's from the SoilWeb group that creates the web app SoilWeb, and so it's basically querying Surgo data, which is the data set that underlies the Web Soil Surveys web application. This is sort of a different format, so it shows up in Google Pro. So you can also get this information by going to Web Soil Survey and going to this same location. But let's zoom out a little bit just to get our bearings. So here's Bill Steiner Family Stadium. This is the North Farm just to the north of it. And then the field we visited on our field trip, it went from this creek down to the road that goes to the farm. So it's the north to south boundary. And then we went from College Avenue to this gravel road that goes through the farm. And so just for this example today, we're going to focus on the terraced section on the north side. And if I click on these, it'll give me the soil information. And for some reason, the OBS studio is not showing the actual soil information, so that's interesting. But if you're actually looking at this on your own computer, what you'd see is that it has the information about the soils that are on site. So it has the mapping unit 3919, Smolin silt loam, 1-3% slopes, and Smolin makes up 85% of that mapping unit. And then if you click on the one to this downslope, it's still the Smolin mapping unit, but it's a slightly different mapping unit. 3923, Smolin silty clay loam, 3-7% slopes, eroded. And so, so we have two different mapping units. We have Smolin 1-3%, Smolin 3-7%, and eroded. So two different phases of more or less the same mapping unit. So that is our soil that we're going to go with, and so 3923 was the particular mapping unit label that's on here. So let's go back to our model, and we're going to choose a soil, and we've already set the county location, so it defaults to all the information there. And we said 3923 was one of these. So 3923, Smolin silty clay loam, 3-7% slopes, eroded. So that's our mapping unit that we want. And we can also switch the mapping unit component to other components if maybe there's one inclusion within a mapping unit that is more susceptible to erosion. We can actually set it to that to kind of predict what would be a worst case scenario if the entire mapping unit was that soil series. But in this case, the only option is the primary map unit, which is in this case a consociation, which is 90% the Smolin series with a few other soils that exist on site as well. So also one thing to note is that for the Smolin series, it gives you the t-value, which is our tolerable erosion rate. So just kind of some interesting information to include there. And actually, I forget there's a little checkbox here. So we can have it do one of the other mapping unit components if we uncheck this box. So, but they try to make this version of the WEPP be a little bit dummy-proof so that you don't accidentally kind of mess with some of the knobs and get some weird results. So you could probably just leave this checked and just go with the default soil series component within that mapping unit. Okay, so everything looks good here, so I'm going to go ahead and click Save. And now we have our soil set for the model. So we have our client name, field name. It adjusted the latitude and longitude when we changed our location. And click on this map button. We got Riley County in Kansas, and we got our soil set. So all the top information is all set. Now, if you were paying attention to the map units that were described there, at the top of the hill, we had 1-3% slopes. At the bottom, it was steeper. And so if we think about our slope shape that we would have, we could have a uniform, which would just be like a linear line going straight up and down the hill. We could have a convex, which is where the hills kind of bulging out. So think of that like a shoulder position. Or it could be a concave, which is more like a foot slope position. And then we have an S shape, which is exactly like what it sounds. And I think an S shape is probably the most accurate depiction of what we had on site, where it's flat on top and steeper on the back slope, and then it kind of flattens out right next to the stream. So we're going to go with S shape here. And then our mapping units is 1-3% slope on the top, and then 3-7% on the bottom. And I think let's go with 4% in this case, just because we got two different mapping units. One is 1-3, one is 3-7, so 4 seems like the middle range there. And then the aspect, this was highest at the west side, and the hillside was facing east. And so that means our aspect is an east-facing aspect. And then let's go back to Google Maps, change my view here, and there's one tool I want to use, and this tool also exists in SoilWeb or Web Soil Survey, and that is the measure tool, which is a little ruler tool here. And if we go from the top of the hill to the bottom, feet. I don't think it gave me my info. All right, 385 feet. There we go. So this field from top of the hill to the bottom is 385 feet. So let's try to simulate that scenario. So 385. And I just realized this tool is not showing up on your guys' screen. You can see my cursor, but there's a little box on the screen that says ruler, and then I go on the tab that says path, and 385 feet. So, so we'll go with that. And let's switch views back to my browser. All right, so our length is 385 feet. All right, and then let's do a couple scenarios here. So let's do one where it's zero barriers, and let's do tillage up and down the hill. So if this is east facing aspect, this would be like running all tillage and planting going east to west or west to east, straight up and down the hill. So kind of a worst case scenario for erosion. So I think we got all this stuff set up pretty well. And then let's do a management. And for this, so I'm making sure we got everything set right here. So we can click on Choose Management, and it goes to this page. And notice that it has the CMZ. So CMZ stands for Critical Management Zone. And it's basically maps of areas with similar agricultural practices across the U.S. And there's a map that we can use. So right here it says CMZ Maps. And in Kansas, we are part of the North Central area. And it brings up this little screen. And if you scroll down, Riley County is right here. And it is in CMZ 24. And so we're going to go with CMZ 24. And so on this drop-down menu, click 24. And from here, we can actually expand this menu. And we can either do a single year crop rotation or multi-year, or if you're doing a site that might be disturbed due to construction sites, you can click on that and it brings up some other options for you too. But we're going to go with multi-year crop rotation. And going back to our questionnaire, try to bring it up so you can see it here. So here's our questionnaire that we got from Dustin Ritter, the farm manager. And on our questionnaire, he said that this is a corn, soybean, wheat rotation. It's currently a no-till, and they had switched it from reduced tillage back in 2022. And so they had a reduced tillage practice, and now it's no-till. So that is our kind of current scenario. And try to see if there's anything else that we need to think about for our management. Try to maximize residue. Not grazed. They don't have cover crops. They do in-furrow or banded phosphorus applications, split nitrogen applications. Not irrigated, no ponding, no problems with crop emergence or early crop growth. Highly variable productivity, which gives variable residue levels. So All right, so that's all the things that Dustin kind of mentioned that we can keep in mind as we work on adapting our management to this. So let's go back to the model. All right, now it was corn, soybean, wheat, so we can click on 3 crop rotation. And there's a lot of text in all these options, and it gets kind of difficult to figure out exactly what the best approach is, or best sort of preset way to do everything. So in this part of the world, the CMZ, the USDA basically predicts that a very common rotation is corn, soybeans, wheat. And if we look at these details, we got corn, no-till, anhydrous being put in, soybean no-till, and double disc, and wheat no-till. No-till. Yeah, so it's corn, soybean, wheat. This there's disking that's put in place. So there is some disking between soybean and wheat, but they've switched to full no-till. Actually, that might be the planters that we're talking about. So pardon me while I kind of work my way through the options here. You'll probably have to do the same for your work as well. But so they got corn that's field disc cultivated, soybean no-till, double disc openers, and wheat. Let's see. I think this number 4 probably looks about the best. And so we can click on View and Edit. And once we do that, it actually shows up all. It shows all of the different operations that we could that is included in this management file. And so what they're showing is on the left side there's a date, and instead of having an actual year like 2024 when this was recorded, it would have just year 1. And so year 1 they're doing corn, and then year 2 is soybean, year 3 would be wheat, and again wheat would span the winter going into to year 3. Then it would be fallow from that point up until they do corn again. And one thing to point out is, let's see, anytime there's a blue check, that basically means that whatever was growing on the field was harvested and everything's dead. So it kills all the vegetation, and it kind of turns off some of the plant models and so on for that work in the background of this model. All right. So I think this is actually pretty good with, or pretty well aligned with what Dustin had described for the field. You are welcome to make some changes to this. And so to do that, you can click Add Management, and you can also like right-click on these and insert or copy or cut and so on. And so you can adapt this management file to whatever the management is. The key thing is you just want to make sure your dates are correct. So what time of year would you actually be doing something like using a sprayer to kill any weeds prior to planting corn, for example. So you want to make sure your timing is all correct. And then you can change your crops by clicking on this. In this case, it's corn, grain, seed. We can change that to another crop if we'd like to. And you can also do other things that impact the residue and yield and so on. So yeah, I think everything looks pretty reasonable for this. And so I'm not going to make any changes. And so in this case, I'm just going to say use this management. And so we have this management file. And they did say no-till. So what we're going to do is the first simulation is just going to be like the current scenario is no-till. So let's do and I know there's terraces there, so they do have contouring. And the row grade is like how much slope there is within a given row. And I don't know, we'll say at 1%. And then for strips and barriers, there are no strips, but we could do something like a contour buffer strip, or like a grass buffer strip, or we could do like prairie strips, something like that. But that's what would be included in here. But there's currently not anything like that, so we're going to leave that as it is. All right, and then I think we're pretty much ready to go. So S shape, 4% aspect. All right, so this first scenario, what we're going to do is run it as if there were no terraces there. And so we're using the full length of the field, 385, or full length that the water will be able to travel if it didn't run any terraces. But we do have contour tilling, or contouring on the field. So we have everything ready to go. And I think we are ready to go for our run. And so to do that, we just click Run. And now the model is running. So we're going to sit here and wait for a few minutes, and then eventually it will pump out like a PDF report. All right, and this first one, I'm going to go ahead and mark it as testing. So I'm going to click OK. And notice that in the results, it will actually kind of populate all these numbers with what the results were. And then we can get a PDF simulation. And so it's probably not going to show the download here. See if I can get this showing up on the screen. All right, so here is the results from the simulation, and a couple things to point out. So it's estimating that if we have no-till on contouring like we have currently, the erosion rate is actually pretty good, 1.19 tons per acre per year. So we're well below 5 tons for our t-value. And then a couple other things to point out. So it shows the runoff, so how many inches of water per year actually run off the field as opposed to infiltrating into the soil. The sediment delivery is how much sediment is actually delivered to the edge of the field, in this case going straight into the stream that goes through the area. And what else do we have? It has information about our crop interval, and also how much erosion there is for each of the different crop intervals. So in corn, we have 1.9 tons of soil loss per acre. Soybean is 1.1, and wheat was 0.5. So that's not terribly surprising, since you'd have more stems in soybeans than you would corn, and then even more stems with wheat as you would for soybean. So the more stems we have, the less runoff there is, and the less erosion. And towards the bottom, it has other information about how much fuel was used in gallons per acre, how much stirring there was, which this would be basically like dust being stirred up by all the operations. And it kind of summarizes all the management aspects. And then it has fuel again. So if you, let's say you're a conservationist, soil conservationist with the NRCS, you're working with a farmer and simulating how much, or what the expenses would be for maybe switching from conventional till to no-till, there's going to be a big fuel savings because you're not traveling across the field as much for all that tillage. And so you can actually use this model to calculate how much savings in fuel there would be per acre. And then, yeah, I think that's kind of the basics that are showing up in this outcome. Now, I want to go back to the model, and we have a simulated yield here. So it says 121 bushels per acre for a simulated corn yield. we have a simulated grain yield for our soybean yield and a simulated wheat yield. And so let's say if one of these were or seemed high or low for a particular field, we could go into the management and we can actually do some changes into the yields here. So so there are ways to do that, but we're not going to bother with that today. We'll just kind of leave it as the default. So yeah, so our test simulation went pretty well, and so if we run it again, we'll just run this as our we'll run it, and then when it saves, we'll save it as our default simulation without terraces. And so we're going to mark this as benchmark, and we'll just remember benchmark is without terraces. So click OK, and it's saved that as one of the outcomes. And again, we want to click PDF summary of simulation, and we would download this and save it as option 1, our benchmark. Okay. All right. Now let's go ahead and incorporate terracing. And so to do that, we actually have to break up the simulation into individual terraces. And so let's change views, switch to Google Earth Pro, and I'm going to zoom in a bit. And so there's 1, 2, 3 terraces. And I don't have the exact slopes. I remember the exact slopes here, but I think we can just go with what the mapped slopes were. And so let's do the first one. Again, do the measurement tool, which unfortunately is not going to show up on your guys' screen, but we can click from the edge to the terrace channel, which shows up just a little bit darker. And we get 50 feet for the first one. And then let's do another one from the top of the terrace to the channel of the next one, 127 feet. And then top of the terrace to the channel of the next one, 216. And then top of the terrace to the stream. Never mind, it's doing continuous slopes. All right, let's clear these. We guys do these individually. So the first one is about 50 feet. Top of the terrace, channel the next one, about 56 feet. And then top of the terrace, channel the next one, 72 feet. And then top of the terrace to the stream edge, we have 164. So we had, what, 50, I think about 55, about 75 if I remember correctly, and then we'll go 165. Keep these nice even numbers. All right, so clear those, change views to the browser. All right, now in this case, we're shrinking the length of slope that we're looking at. And so in this case, we can go with a uniform slope. And we're at the top. Let's do like worst case scenario and say a 3% slope because it was a 1 to 3%. So we'll stick with worst case scenario just to kind of simulate this. Or you can either do worst case scenario or you can just do middle. So let's do middle. 1 to 3, we'll go with 2. And still an east-facing aspect. Still got contouring. But we're going to change the length to 50 feet for the first terrace. And we can click. So now we have to do the simulations individually for each terrace section. And so we're just doing it for the top one first. And actually, while it's running, I noticed that we still have a different soil at the top. So I think we have enough precision now that we can actually change this. So I'm going to click cancel. Let's change the soil. we're going to go 3919, which is what was at the surface, or at the top of the hill. So we change the soil to what's actually at the top. 3919, 50-foot length of slope, 2% slope. I think we're all ready to go. All right, so we're going to mark this as, we'll say alternative 1, and we can save the PDF, but just real quick, I can point out what the results were. So we have 1 ton, or 1.12 tons per acre for the top terrace, and the next one was 55. Now, I'm going to skip the second terrace. Let's go to the third, where it was 75 feet. And we're going to change this back to 3923. 3923, small and silt loam, or silty clay loam, 3 to 7% slopes. Save that. Steepness will go, 4% on that guy. And we got 75 feet. So I think we're ready to simulate terrace 3. And we'll save this as alternative 2. Go ahead and click OK. Our slope, or our erosion, is 1.07. Okay. And then let's do our final terrace, which was 165. And I think it actually kind of, I think the slope went down towards the bottom. And so let's put that at 3% slope. So it is kind of like an S-curve where it's flattening out at the bottom, but it's a longer terrace interval here, which, because it's flatter, that's why they do the longer terrace interval. And we're going to leave this as the same mapping unit, 3 to 7%, the 3923 mapping unit. And we'll leave this as uniform. I think we're ready to go for the terrace 4, the bottom terrace. So run that. And I'll mark this as alternative 3. Okay. And at the bottom one, we had 1.01 for our erosion rate. So things are kind of flattened out. Even though there's a longer length of run for the water, it is getting flatter. And so there's not as much erosion in this case. All right. So that would be how you'd simulate terraces. In this case, there's already terraces on site. If you had a field that you were simulating where there wasn't terraces to begin with, you would start off with a long run, kind of like we did in the benchmark, and then you would add terraces and figure out whatever interval is and break it up and simulate each individual terrace as one separate simulation. And so you end up doing as many simulations as they have terrace intervals. We can also do another scenario. So let's go back to, let's do S-shape, and we'll do, we had, what, 4% slope that we assumed for like the whole field, facing east. And our total length, what we say, 385, I think is what we said the total length was. And so in this scenario, so we're back at the benchmark without any terraces. And we could do something like put in strips. And let's say that we put in some cool season actually, let's imagine that we put in a cool season grass buffer strip at the bottom. And so you can say cool season, and we could say bunch grass, or we could say cool season sod forming at the bottom. So let's go with cool season sod forming. And I know at the bottom there's actually a lot of reed canary grass that's growing there. So I think that actually works out pretty good. And then one thing to point out is once we put this at the bottom, then it split our 385-foot slope into 355 feet of cropping and then 30 feet with a grass buffer strip. And we can change that if you'd like to, but we're just going to leave that like it is for now. And so if you remember, I think we had 1.19 tons per acre erosion that was being delivered to the stream. In this case, we've added a grass buffer strip. So let's go ahead and run this scenario. And we got an error. No upwards. Okay. So what's happening is our management, well, it has begin growth. I forget the error said again. Let's run it again so I can figure out what the error said. Oh, I ran it this time. Okay, we'll call this alternative 4, and we'll ignore the error ever happened. Okay, so this is alternative 4, and notice that in this scenario, we had 1 ton per acre per year that was eroded, and then the sediment delivery was 0.92. So we've actually reduced our sediment delivery in our benchmark simulation. I think we had every bit of our erosion was actually reaching the stream, so 1.19 tons per acre. Just by adding a 30-foot strip of grass, we reduced that by 0.3 tons. So think of that as, 600 pounds of sediment per acre per year that's being reduced sediment load to the stream just by adding a little filter strip there. So so that's how we'd add a filter strip if we wanted to. You can also put in these strips or barriers like mid-slope and at the top as well. So there are some different examples that can do that. So there's lots of options for putting in that sort of filter strip. I think putting them next to the stream is probably most common. I don't see many contour grassed buffer strips very often. But if you're in like a big dairy area, one place where I commonly see it is if there's a lot of dairy and there's a lot of demand for forages, then you could do this sort of thing and say a sod forming or bunch grass or whatever. But you can actually go in and change your management file and put in, let's say, alfalfa, and have that be your contour buffer strip. So there are ways to sort of simulate those scenarios in that sort of situation. Trying to think if there's any other model changes that we'd want to kind of demonstrate in this video. I think that's it. So hopefully that kind of gives you a good quick summary of different conservation practices you can play around with. There's lots of things you can change in this model. There's lots of adaptations you can get to get it exactly like you'd want to for your particular site. Usually it means going in and changing things in the management file. But I found that the kind of default simulations are pretty well in line with what practices are used in different regions. So usually you can find one that's at least very close to what you have on your particular site. If you are working with construction sites, it has lots of options for that as well. So just to let's see. Yeah, I'm not not going to bother trying to switch to a construction site, but there's lots of different options for that as well. So so make sure that you explore all the construction options if that's the type of simulation you're trying to do. And then one last thing is if you have a manager file that you like, you can actually save that manager file to your device. So you can click Save Local. And this is really helpful if you also plan to do a WEPP analysis, so the Wind Erosion Prediction System, which, like I've mentioned before, there's both WEPP and WEPPs, and it's confusing to figure out which one is which. But WEPPs with an S at the end is wind erosion. WEPP with a P with two P's at the end is water erosion. But you can take these same management files from WEPP and then take that and upload it into WEPPs, and you can have the exact same simulation, but one is doing water, one's doing wind, so you get the full picture of what the erosion situation is at your site. So one thing to kind of consider. And then also notice there's a button here that says import from WEPPs. So you can actually start from WEPPs first, create your manager file, and then export the manager file and import it here and do the same thing. So between those two models, you get a full picture of kind of what's happening for erosion. But I think that's the basics, and I think we're going to wrap up the video there. Let me know if you have any questions, and take care.